Hello, today we're going to look at the graphs of trigonometric functions. So we're going to look at the graphs of the functions sine, cos and tan. So we've thought about sine, cos and tan in several different contexts, and today we're going to focus on their graphs. So we're going to treat them in the same way as we've looked at the graphs of quadratics and cubics. We're now going to look at the graph of sine, cos and tan. So let's bring together some of the things we've already talked about. Now, if we have the function y is equal to sine theta, and I have the graph of it drawn here, graph drawn in blue, I have y, the y-axis is the same as it always was, and the x-axis as we would usually draw it is the angle axis, is the theta axis. So I have y is equal to sine theta, or y would be equal to sine x. So my x values are my horizontal line. That's my theta axis here, or theta axis. So that's the setup for our diagram. Our input variable is theta, just like x often would be. Now we're going to have a talk about this function in a moment, but remember that sine is the y coordinate in the unit circle. This is the link back that we have to have for more complex questions. We must have a hold of that whenever we're thinking about a more advanced version of sine, cos and tan, that we are dealing with the x and y coordinates of our points on our unit circle. Now, if we go down to our unit circle here and we think about what happens when theta is 0. So when our angle of our blue line here goes down to 0, to the positive sense of the x-axis, which is what we always measure from, well, sine is the y component. So when this point comes down to the x-axis, when theta is 0, our sine is going to be 0, because our y coordinate when we're down here is going to be 0. So sine starts off at 0 because it's the y component. And then when we rotate around, when this angle gets bigger up to 90 degrees, when we'd be up here, then we would have sine being the y component would be 1. When we're up here, we are at 0, 1. Our y component is 1 when theta is 90 degrees, or in radians, pi over 2. So that's the top point here. When we rotate around to 90 degrees, our sine function is at 1. Then when we keep rotating around, our y component starts to go down and down towards 0. Goes down and down towards 0, and it hits 0 at theta going around to 180 degrees, or pi radians. We keep going on down, and we're getting more and more negative, down to -1. So the lowest point on our sine function is going to be down at -1, down here on our unit circle. And then we keep rotating around even bigger and bigger. Our angle is all the way around to somewhere like here. And now we're still negative, but we're getting closer and closer back up to 0 again. And if we continued the graph on, it would just start to repeat itself. It would keep going and keep looking like that. It would just keep on going in the same way. So that is the general way that the sine function works, and we can see that from what we know about the unit circle. So that's our sine function, and that's where it's coming from. Now, where our function starts to repeat itself, so we start at 0, we go all the way around, and then we start to repeat ourselves past this point. Our function starts doing exactly the same thing. It's rising from 0, comes to a peak, drops down again. It starts repeating itself when we have gone through 2 pi radians, or 360 degrees. When we have gone one complete rotation all the way around, we start repeating ourselves again. We start getting the same y outputs again. So we say that this is one complete period. A period is how long it takes for our function to start repeating itself. So that is our sine function. Now, its domain, that means its input values. Domain is input values, effectively its x values. Go from -infinity to +infinity, or the real numbers. You can put in capital R instead of this interval if you prefer. And that just means that we are can put in any theta value we like. There's no value of x, no value of theta that isn't defined for the sine function. Its range means how its maximum and minimum y output. Well, it's extremely important that we know that the sine function has a maximum of 1 and a minimum of -1. This is actually a requirement and makes some exam questions a hell of a lot easier, because looking at the maximum and minimum of functions is an important thing that we do at some points in our course. So our maximum value for our sine function is 1 and our minimum value is -1. And you can see why that is either from the unit circle, the y values being between plus or -1, or on our graph that it's between plus or -1. This is our range of values. Now, that's our sine function drawn as I have it here. I'm going to change the screen now so we can see what I've just discussed with you in GeoGebra. So we have our sine function, and I'm going to vary the angle by moving our cursor here, and we're dealing with y is sine theta. So I'm going to change the value of theta. When theta is 0, sine is 0. We'll start to see this output in just a moment. I'm going to bring this up now. You can see as I increase the angle, sine is getting larger and larger. I'm going to bring it up to about 60 degrees. We can see that sine of 60 degrees is about 0.866. And we can see that the y component of my coordinate here, of my yellow dot's coordinate, the y component of that gives me the sine output. Now, if I rotate around to 120 degrees, I know from my work with the unit circle that I should get the same output for y. And my y output, when I go around 120 degrees, because I've gone 60 degrees up from the negative x-axis here, I end up with the same y value of 0.866. So I'm getting the same y output when I go around to 120 degrees. What other ones should give me similar ones? Well, I should get negative 0.866 if I go down 60 degrees off of the negative axis here. So what would that be? That would be 240 degrees. So at 240 degrees, I'm at minus 0.866, and I can see that I have gone down. I'm now underneath the y-axis, underneath the x-axis, and I now have a negative y output. If I go around again so that I'm 60 degrees down from the positive x-axis, 60 degrees less than 360 would be 300, I'm again getting the same y output as I did back here. So you can see where we're getting our repeated values for y that we've discussed in the past. Now what happens if we go all the way around to 360 degrees? We have gone through one complete rotation. We've gone through one complete period. So from 0 to 360 degrees, or from 0 to 2 pi, is one period for a sine function, for a simple y is equal to sine theta function. And for some other key points on this, if we're at sine of 90 degrees is 1, you can see that we've gone through an angle of 90 degrees. Our y component in our unit circle is just 1, and our sine function is just 1. So we can play around with this and get all of the different values that we have gotten used to getting out from the sine function. And we can see if we go through 180 degrees, sine is 0, just like it is when we have sine of 0 degrees. So that is what we've got for our sine function.